Objective 5 from this section is obtaining information about the function from its graph. You can obtain information about the function from the graph. At the right or left of the graph, you will find closed dot or open dot or arrow. If it's a closed dot, that indicates that the graph stops there, does not extend beyond this point, and this point belongs to the graph. If it is an open dot, this indicates that the graph does not extend beyond this point and that the point does not belong to the graph. And if it's an arrow, that's going to indicate that the graph extends indefinitely in the direction in which the arrow points. I have in example 7 here a graph to demonstrate that. We can see an open dot to the left. That means this graph is gonna stop at -5, but -5, the x value -5, is not going to belong to this graph. While if you look at the positive direction, at the right direction, I can see that at value 6, that's a closed dot, and the closed dot means the graph stops here, and 6 is a value from the domain of this graph. The domain again is going to be the input of the x-axis, and the range is going to be the output of the y-axis. X-intercepts, or zeros of this graph, is going to be the x-coordinate of the point where the graph intersects the x-axis. The zeros of the function f are the values of the x value for which f of x is equal to 0 or also y is equal to 0. Thus, the real zeros are the x-intercepts. Y-intercept is going to be the y-coordinate of the point where the graph intersects the y-axis. Pretty much, x-intercept is going to contain value for x, y-intercept is going to contain value for y, and on the y-intersect the x is 0, and the x on the y-axis x is 0 and the x-axis y is 0. Let's answer those questions. Use the graph to determine the function domain. Okay, what are the possible x values plugged? We can see that we cannot plug in -5, but we can plug all the numbers after -5 up to number 6 and number 6 included. So I'm gonna say the domain of this function is x belongs to the interval from -5 not included to 6 included. What is the function range? Well, the function range is going to include the y values. The lowest y value I can see is over here at -4, and the highest value for y I can see going up to 5. There are no points of exclusion, so the range of this function is going to start from -4, continue to 5, and takes all the values in between. So the range is going to be included -4, continuing to 5. And 5 is also included. So when I state what are the domain and the range, I'm going to be thinking not what kind of different values or how many times this this graph crosses through each point, but I'm going to be thinking what possible y values this function gets to answer the range, and what possible x values this function need to be drawn. Now, there is no question as if this is a function or not, but you may think, is there a place that if I cross with a vertical line test, I'm gonna intersect twice? And it is obvious that everywhere this function can be crossed just once, so I would say this is a function. based on the vertical line test. Well, let's answer the question, what are the x-intercepts? So for x-intercept, I'm looking on the x-axis. Where exactly this function crosses the x-axis? And I can see that this is one point of intersection, and this is another point of intersection, and that's another point of intersection. So the x value for which the x-axis is crossed are -4, +1, and 5. Or if the question is, give those x-intercepts in point notations, you would say -4, 0, 1, 0, and 5, 0. To find the y-intercept, I'm gonna look at the y-axis. Where is this graph crossing the y-axis? Well, it crosses it only this one time, at -3. So for y is equal to -3, that's the y-intercept, which written in point notation is going to be 0, -3. The y value is -3. What is f of 4? Let me select different color. F of 4. What does this mean? Well, this means when x is equal to 4, what is y? Or I'm looking at the point 4, what? Here, what is the y value? Well, x is equal to 4 at that level. And the point on the graph looks like to be the point 4, 3. So that means f of 4 is equal to 3. The next question, find OX such that f of x is equal to 5. Well, what does this say? F of x is equal to 5. F of x is the y value. So y value to be equal to 5 are all the points on the level of y is equal to 5. And on this graph there is only one such. Maybe more, but in this case that's just one. And it looks like this is the point 2, 5. So then I would say for x is equal to 2, the y value is equal to 5. Or that's the same as the point 2, 5. Let's repeat this exercise with a different graph. Use the graph to determine the following, the function domain. Well, where is the first value of this function? There is no really an empty dot, but I'm going to assume that this is a complete dot, full dot. And I'm going to think, okay, the first x value is at -1. And there is nothing between, before -1. So the domain doesn't have any previous values before -1. So it starts at -1. Provided that -1 is included, provided that this is a full dot, I'm going to put a bracket. If it was not included, as in the previous case, I'm going to put parentheses. But here that's a bracket clearly because it's included. And then, how far do the x values go? Well, notice that I don't see anything past 3, but this is because my graph is going to continue indefinitely. At some point, it's going to get all those values. So the domain, which is what are those projections of all the points over the x-axis, I can see that they go all the way from -1 to +infinity. What is the function range? Well, the topmost point here I can see is at 3. And since this graph goes low to negative infinity with that arrow showing me that, I'm gonna say, well, then the range is from negative infinity to 3, and 3 is included. Notice that I did not say 3 to negative infinity because we never go backward. We always state the intervals in increasing order. So such notation is going to be wrong. What are the x-intercepts? Well, let's locate the x-intercepts. It looks like the x-intercept is somewhere right before 2. So I'm gonna roughly say that's 1.8, for example. I'm gonna say let that be 1.8, that point here. And I'm gonna say, well, the x-intercept is at 1.8, or if I wanted to write point notation, I'm gonna say 1.8, 0. What is the y-intercept? Well, the y-intercept looks like it's right at the top of this graph, which is the number 3. So I'm gonna say the y-intercept is y is equal to 3, or in point that's gonna be 0, 3. What is f of 2? F of 2 would mean x is equal to 2. And x is equal to 2 at that place right here. So this is the point 2, -1. Since that's the case, f of 2 is going to be -1. Or f of 2 is the y value when x is equal to 2. So y is -1. Find all x's such f of x is equal to 2. F of x is equal to 2 means the y value is equal to 2. Let's locate y value equals 2. Let me select different color. Y value to be 2. Well, there is one point if I go to the right and another point if I go to the left. And that point has coordinates of 1, 2. And this point has coordinate of -1, 2. So there would be 2 such values for which x is equal to, for which y is equal to 2. And those would be the x values of -1 and 1. And both of those would produce values for values of y to be equal to -1. With this, I'm concluding the following lesson.